So last unit was all about confidence intervals. We did it with 3 types of data. So we had proportions, confidence intervals, means using T, and then means using Z. And what were the differences between means using T and Z? Yeah, sample versus population standard deviation. So T went with sample and Z went with population. We're going to do the same kind of process, but instead of a confidence interval, we're now going to run a hypothesis test. So a hypothesis is a statement or a claim about a property or characteristic of the population. So that's kind of the formal definition that you might see on a test or a quiz or something. If I were to summarize what a hypothesis test is, it's when you hear a statistic that you think is known. So I think I have an example in here somewhere, but the other day I read something that said 5% of TV remotes are found in the fridge or in the freezer when they're lost. 5% of TV remotes are found in the freezer.
That's a sign of Alzheimer's.
No.
5%. And then 50% are found in the couch. I feel like that's pretty valid. 50. Yeah.
It's easy to leave it in the fridge.
No, I've never done that.
I've done that so many times.
I've never done that. In the couch. So, anyway, those are statistics that are supposedly known, that are population characteristics. All TV remotes in the world, 5% of them are lost in the freezer or the fridge. But you may think that that number is wrong. So you want to try and prove that number to be wrong. So you're going to run a hypothesis test and try to prove that wrong. Maybe you think that number is too high. Maybe you think that number is too low. Whatever it is, maybe there's some absurd statistic that you read that you just think is wrong. So your goal in a hypothesis test is to prove that wrong.
Don't most people in China and Africa don't have 5% of people.
Okay, so we've got confidence intervals and we have hypothesis tests. Does anybody want to summarize in their own words what they think the purpose of a confidence interval is? We just did a project on it. What was our purpose? To what?
To estimate the average.
To get an estimate, and an estimate of what?
The average.
The average of something.
The average of the sample population.
Are we trying to estimate the population?
No.
Yes, we are. We're trying to. So we take a sample. So we take sample to estimate the population. So Cameron and Tatum, y'all measured the amount of sleep for PCA seniors. The population would have been all PCA seniors. There's 120 of them or so, right? But y'all did not sample every single one of them. You only sampled 60 of them, right? Yeah. So you only sampled some of them, but you estimated what the entire senior class would be. So you're taking a sample, you're trying to estimate a population. It also gives you a range of values. So basically, I'm 95% confident that that the population parameter is between these numbers. The main point of a confidence interval is that your population average or number is unknown. We don't know it. That's what we're trying to find out. We don't know it, but we're trying to find it out. A hypothesis test is kind of backwards. So the population is supposedly, how do you spell supposedly? Not right? Is that right?
Yeah.
Yes.
Supposedly known, but you are trying to prove it wrong. So you're going to take a sample to attempt to prove wrong. So that's kind of the whole goal. You take a sample. I'm going to attempt that by my sample that you're trying to prove it wrong. So going back to Cameron and Tatum's project, if the counselors at PCA had this statistic in one of their files, so they said that the claim is that PCA seniors get an average of 8.4 hours of sleep a night. That is the average, and that is what is known. That's what they advertise on their brochures to every single parent at PCA. That's what they advertise. But you guys think that's completely wrong. That is not accurate. They are lying. So you're going to run this hypothesis test to prove it wrong. So you take a sample to PCA seniors, and what was your average? Like 6 point something. Well, you would take that average, compare it to the 8.4 that the PCA counselors are lying to people about, and then you try to compare those and prove them wrong. So we're going to run a hypothesis test and prove that wrong. So that's what a hypothesis test is. Okay, so here's an activity just to kind of take you through the process. What I want you to do is pick, yeah, I don't know why it does that. Pick a 2-digit number between 10 and 50 where both digits are odd and the digits do not repeat. Think of the first number you think of. Shh. Okay, does everybody have it?
Yeah, do I need to write it down?
Write it down right now. So what you'll do in your calculator is you're going to go to math probability 7. And if you have an Inspire, I didn't write the rules for that one, but whenever we did that random integers, like the random numbers, y'all remember doing that? No. On the Inspire?
I'm not good.
It's like probability.
It's like probability.
You want the one that says rand and then B, like rand bin.
I do not know how to work this.
Binomial?
Mm-hmm.
Okay.
And what I want you to type in for N is going to be 15, and then 14. And then P is going to be 0.125. And I want you to do that 4 times.
Yeah, rand bin. It just says rand bin and then.
Oh, parentheses. So do 14, comma, 0.125. And I want you to do that 4 times and record your 4.
Yeah, how do you get a comma? Bottom. And then parentheses, 14, comma, 1.
Yeah, 14, comma, 0.125.
I got 1.
Okay.
I did too.
I got 1632.
1632.
I did not get that.
That's what I got. That's what I got.
1632?
Yeah.
That's because all of your seeds are the same.
I
Do
got
you remember
1.
changing that seed?
Nope. No, I borrowed this from over there. I did too.
You got to change your seed to something different. So that means like we were just gathering more data. So the more and more we sample, the closer it could be to 0.125. So is our class proportion surprising? No. So people think that 37 is more often chosen, but we just don't have enough data. We can't prove it wrong. Amongst our class, where we only have like 14 people, it was a little bit higher, but the more and more we sampled, it got closer to the 0.125, so it's not different. So here's some other, and I just gave this one about the statistics that I read, but one of them says 5% of TV remotes are found in the freezer or the refrigerator. Another one that you could maybe try to prove wrong or you think is too high or too low, it says, does a majority, more than 50%, of the population favor a new legal standard for the blood alcohol level that constitutes drunk driving? So do you think that more than 50% think that the blood alcohol content should be raised before drunk driving? So some people think that number is too high. Some people think that's too low. That's something that you could test. That's a hypothesis test that we could run. We just did that. So a test of a hypothesis, if I were just to summarize, it's a method where we use sample data to decide between two competing claims. Yes. It just says, what is a test of a hypothesis? So essentially, is the sample that we take, is it something that's likely to occur? Is it close to our population claim? Or is it something that is really different? So is our sample, because the claim that is made is always going to be in the center. So like 5% of TV remotes are found in the freezer or the refrigerator. Or PCA says that seniors get 8.4 hours of sleep per night. That's going to go in the center. Then you will take a sample and compare it. So Tatum and Cameron got an average of 6.25 or something, right? Around that. So basically, is this number different enough from the 8.4 to prove it wrong or not? That's what a hypothesis test tells me. My guess would be yes, but we're going to run the test mathematically. You're going to start with writing, do what? Yes. This one?
Okay.
We're going to learn how to set it up. We have to start by writing hypothesis statements. So there is a null hypothesis, which we call the hoe.
Oh, reject the hoe!
Yeah, I remember that.
I'm happy.
That's gonna be
I'm
funny
happy.
when I watch this.
Like, do we write this down?
Except
Yes.
Oh, we do have to write that down.
Yes.
Wait, what did I write down?
So a null hypothesis is a claim about the population that is initially assumed to be true. Just write it next to the dots.
Oh, wait.
Like the colon. Just write that definition.
Oh, they're wrong. That's okay.
You said right next to
The colon, yeah.
I don't know why. Southern is fine.
And then write the other one underneath that one.
Uh-huh.
Wait.
You sounded it out. Oh,
Southern
addition.
noted.
Denote.
I'm smart, guys.
It's almost funny. Thank you all.
So under HA, we just put the computer.
I think they show up in a minute.
You don't even have to rank
I love you
it
too.
by ha. That's not it, sir. It's this.
Oh, wait. Oh,
You
I
are
guess
Right
it
into
is.
the wrong thing.
Okay, these are what you need to put at the bullet points. Hypothesis statements are always about the population, never about the sample.
You just said right.
Just if you have all of that on there, it doesn't matter where they go.
Wait, do I need the second one?
Put this next to null hypothesis.
All of this?
These two things.
Not the alternative hypothesis.
I'm so.
The alternative hypothesis is already written for you.
Oh,
I wrote
alright.
it again. So
Yeah, no.
I did the null hypothesis.
Oh, no.
Right.
Bobby, I was right. Never
Never
say no to
say
that
never.
host.
I don't know.
I was right.
You always
Yes,
reject
it was.
the
But
host.
it's focusing so reject the host.
Good.
Because they're not here.
Okay. We have that written down.
No, I did the host.
Almost.
I know, but that's like, you don't have to.
That's fine. Now I have flat
Oh,
marks
that was a
all over
bad
my
joke.
page.
All right, so let's think about
Guess lunch, Lindsay.
let's think about a murder trial. What's the null hypothesis? What is believed to be true?
Wait, what was the second one? I missed the second one.
Innocent.
I
Innocent.
wait, I missed the second one. I didn't get the first one.
What's
Somebody got
believed to be true?
Becky murdered.
This is what you assume to be true before you begin. Before you start. That they're innocent.
Assume he is innocent.
So we assume that they're innocent until
Reject the host.
Maybe it's
You
forfeit.
cannot assume
we're
that.
trying to prove them to be guilty. So that's what I believe, but everyone else claims that this person is innocent. I'm going to go in and try to prove that person guilty. So that's my competing claim. The only way that we can prove this person to be guilty is if we have what?
Evidence.
Evidence beyond a reasonable doubt.
Doubt.
So,
That's right.
do we ever prove this person to be innocent?
No.
No, we either prove them to be guilty or not guilty. That's kind of how this works. We don't ever prove innocence, we just prove them not guilty. So that's how a hypothesis test works. We either reject the null hypothesis, meaning I'm in favor, I've proved this person guilty, or we've proved them not guilty, but we've never proved them innocent. So we either reject the null hypothesis or we fail to reject, but we never accept the null hypothesis. So you don't ever accept a hoe.
Always. Yeah, you always.
No, never accept a hoe. Don't ever.
accept a hoe, CK.
So
May I say it again for you?
we will make two decisions. We'll either reject the hoe or we'll fail to reject the hoe, but you'll never accept the hoe.
Never accept the host, CK.
Never accept the hoe. Don't do it.
CK, stop
We
doing
either
it.
gonna reject the vote or fail to reject
Okay, I guess these notes were a little messed up. I want you to write these two bullet points in the null hypothesis too. If you just need to write it at the bottom of the page and draw an arrow, that's fine. As long as you have this information on your paper. Doesn't matter where it goes.
So y'all want me to put it on there,
null
bro?
hypothesis, a statement of no effect. Wait, does that mean-
Put it somewhere and draw an arrow to null hypothesis if you need to.
We're gonna make it work.
Make it work. hmm
I walked past Elsa, and you said that it wasn't bad, and I was like, ooh,
I know.
feel bad.
Okay, so there's three ways. There is a less than, greater than, not equal to test. So my null hypothesis will always look like this, where it will be my population characteristic will equal the hypothesized value, and it'll be given in the problem. So population characteristic could be your population proportion, like it could be P, it could be mu, it could be sigma, could be standard deviation. It's just whatever your population parameter is equals some sort of value. And this will make a lot more sense once we do an example.
So where are we writing that?
Then your alternative hypothesis, just under number 1.
Oh wait, this is on number.
Wait, that's number one. We only have alternative hypothesis. Yeah, we have.
Okay, listen. So I'm going to write it out for you. So number 1 says equals hypothesized value versus not equal to. So the null hypothesis is going to be population equals some sort of number. The alternative is that population characteristic is not equal to some sort of number. Number 1. Number 2, equal versus less than. Your alternative hypothesis is that population equals some sort of number. The alternative is that population is less than number. 3, the null hypothesis, population equals a number. The alternative is that population is greater than number. So the difference is you could have a not equal to test, you could have a less than test, or you could have a greater than test. Here's the calendar too. So basically, you think that the number that is given is either too high, too low, or you don't know what it is, but you just think it's plain wrong. That would be a not equal to test. So a not equal to test is going to be considered a two-tail test. But less than and a greater than, those are going to be considered one-tail tests, meaning they just go in one direction.
Number 1, 2-tailed.
Mm-hmm. 1 is two-tailed, 2 and 3 are one-tailed. Less than and greater than are only one tail. So we're going to go through on the next page hypotheses and see if they are correct or not. So some things we're looking for are they have to be a population characteristic. The null hypothesis always has to be equal. So it's equal no matter what. The null is always equal. The alternative is always less than, greater than, or not equal to. Okay, so here's A. We've got mu equals 15 and mu is greater than or equal to 15. Do we think that this is good or not good? Not good because why? Perfect. Must only be greater than, can't be greater than or equal to. So I want you to correct it by changing the greater than or equal to just be greater than. What about B?
Or the X bar.
X bar. What's wrong with the X bar? It's not a population, it's a sample. So instead of X bar, it needs to be what? No. Mu. X bar goes with sample mean, so it's population mean. What about C? Is it okay? C is good. What about D? There's something wrong. They have to be the same number. So cross this one out. It needs to be 2.3. What about E? You need to flip the signs. The null hypothesis always needs to be equal. So, 3 facts to remember about hypotheses. Hypotheses always refer to populations, not sample. The alternative hypothesis should be what you're trying to verify, like what you believe to be true, compared to what society believes to be true. And then thirdly, we're always going to define our parameter in context. Hypotheses for the magic number activity that we just did. So the null hypothesis would be, what is the proportion of times we expect somebody to choose 37? 0.125. So P equals 0.125, 1/8 of the time. But people believe that it's what? Greater than that? Yes. So people believe P is greater than 0.125. And to define my parameter, P equals, or P represents, the true proportion of times 37 is selected. That's what the P represents. So you have three things: the null, the alternative, and this is what defining your parameter means in context. So that's what these examples are going to look like. Three things. So let's go to the next example. Example 1, determine the null and alternative hypotheses and the tailedness, which just means, is it a less than, greater than, or not equal to? And you'll be able to decide that by reading the question. So, according to the Gallup poll, 74% of Americans felt that men were more aggressive than women. A researcher wonders if the percentage of Americans that feel men are more aggressive is different today. So, I'm going to highlight number. I'm going to highlight different.
How are we supposed to know if it's better than you're right?
By what the problem says.
Okay.
So, my null hypothesis is P equals 0.74. The alternative, what direction do we think it's going? It says different. Not equal to, because it just says different. If it said higher or something, then we would do a greater than. If it said lower, less than. But if it just says different, that automatically means not equal to. And P represents what? The true proportion of, what are we measuring?
Aggressiveness in men?
Of Americans that felt men were more aggressive. I'll mark this out. It's on the next slide. Okay, next one. The packaging on a light bulb states that the bulb will last 500 hours under normal use. The consumer advocate would like to know if the mean lifetime is less than 500 hours. So, I'm going to circle what I need. 500 and less. Null hypothesis, what symbol am I using? No. What symbol? No. P? No. Mu. Because it's mean. Mu equals 500. Alternative, mu is less than 500. Mu represents the true mean, what? Lifetime of a bulb. Okay, C. The standard deviation of the rate of return for a certain class of mutual funds is 0.08. Mutual fund manager believes that the rate of return is less than 0.08. So, I've got less, and then I've got 0.08. My null, it's talking about standard deviation, so what's my symbol?
Standard deviation.
What is that?
Circle.
The little O is called sigma. Equals 0.08. Sigma is less than 0.08. And sigma represents the true standard deviation, what? Of the rate of return for mutual fund. Okay, I want you to try the next three on your own, maybe with someone next to you, and then we'll check them. Then there will be some time to probably finish your homework before the end of class today. Here's the example for A if you want to check it.
What's the example for C?
We're getting there.
I got B.
Good with A? Okay, here's part B if you want to check your answer for this one. Okay, here's the last one. So sigma equals 0.23, sigma is less than 0.23. Yeah, that's a good question Oliver asked. Do I have to write out the whole thing? Yes, you do.
What if we happen to miss a small for B? I didn't put in the Miami metropolitan area. What is that? You gonna count on?
A little bit, yeah. Yes.
Rewrite the whole time.
You still are talking, you circle the population number and use that. Okay, let's look at the homework. Shh, listen. Go to the homework and let's look at number 2, okay? So, in number 2, if you read that, it says that in a random sample of 1,000 adult Americans, only 430 could name at least one justice who is currently serving in the U.S. Supreme Court. A claim is that fewer than half of adult Americans can name at least one justice who is currently serving on the Supreme Court. So it gives me 2 numbers in this example, but I only use the population one. Okay? So do not use the 430 out of 1,000. That's a sample. Later on, when we run the test, we'll use it. But for now, we're looking at the fewer than half. So, listen. So, fewer than half. So, the claim is that, would this be a P or would this be a mu? P, because it's out of 1,000, like out of. So, it's a proportion. P equals 0.5, but I think that it's less than that. And P represents the true proportion of people that can name blah, 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 blah.
Can we write that?
No, you have to write it.
Can we write it?
Because I helped you with one of your homework problems, so I don't have to write it out. So make sure on these, when you're reading them, there's going to be two numbers given to you, but you only use the population one. So use population number, not sample.